Professor,
Yeah.
I have to leave. I have to leave early today at 6:20. Is that fine?
Say again.
I have to leave early at 6:20 today.
Okay. All right. Good evening. Before we start, I got a couple of announcements. The next week, Monday and Wednesday, we're gonna have asynchronous lecture. So you're going to have about 2 videos that you're gonna have to watch, and make sure that you send me the attendance email that you have watched. The other is that I finished the grading. Everything should be updated. I asked you to watch the video on Monday for the exam review. So I need you to go through that. The next time that, if it's not too much trouble, if you guys can, scan your test using, a PDF file, just I think I mentioned that, those who submitted like a picture file, several different picture files there, I ask you to submit it as one single PDF file. The reason for that is if you submit it as a one single PDF file, I can download it to my iPad. I can actually make a comments on it. And some of you have done it. So those I think it's 4 of you, like 5 of you did that. So I was able to download it to my iPad, and I give you my comments, then I upload it back to the Canvas. So that's much easier now. If you just submit like, several different picture file, then I cannot do that. So that's why you see that, without any, I mean, I wrote the comments, but not in detail. So that's what you see in the Canvas. So maybe next time, if you want to see, more detailed comments from me, then just submit it as my single file, PDF file, and then I can download it to my iPad and give you my comments, more detailed comments. All right. Okay, so today we are going to go over the rational exponents. Now, this is the topic that a lot of students get stumbled. I don't understand why, because the rational exponent is pretty much same as the irregular exponents. Okay, so I'm going to share my screen. Okay. Now I'm going to start with just, two radicals. Let's say we have square root of x. Okay, if I want to rewrite this as a rational exponent, this is going to be same as x to the 1/2. If I have the cube root of x, and this is going to be 1/3. Okay. Now, the laws of exponents still applies to these rational exponent as well. So you're going to have to go back now. The laws of exponent applies. Okay. So the product rule that will be a to the m times a to the n. It's going to be a to the m plus n. The quotient rule, okay, so if I have a to the m over a to the n, you subtract it. And then we have a power rule. So if I have a to the m to the n, that's going to be m times n. We also have, negative exponent rule. Okay. So negative exponent rule is that anything to the negative is going to be same as 1 over positive. So we use these rules to, conduct the operations on the regular exponents. And as you can see that, it's not going to make any difference whether you have rational exponents or not. It's going to be the same rules that we're going to have to apply. So what we're going to do today is we're going to look at some areas that, using the rational exponent and using that to simplify some of the rational exponents. Okay, so now before we move on, then there's a couple of areas that we need to look at. Since we are dealing with the radicals, okay, now one thing about the radical here is that you cannot have any negative in square root. Okay, so here, if you look at the, where is my, yep. So over here, if you have a square root, okay, that x cannot be negative, okay, for this class. Now on the cube root, it's okay. All right. So those are the couple of things that we need to remember. Okay, so and the other thing here is that we're going to have to look at the radicals. Okay. What I just explained it over here is the what we call square root and power. Now n becomes the rational exponent. Okay. Equals to b means, okay, a equals to b to the n. Because you're going to have to multiply the both sides by the reciprocal of n, because a to the 1 over n. So in order to make it a, you're going to have to multiply the both sides by reciprocal of that n, and that's what you get, n on the right hand side. So here's let's look at a couple of examples here. Okay, so if I have, I'm just going to give you some example here. Okay, so give me a second. Let me just get down here. Remember, we are applying the laws of exponents for all the examples that we are doing here. So I have a minus 16 to the 1/4. Okay. We want to evaluate them when we try it without using calculator. If you want to evaluate something like this, the best way here is to rewrite the base using the smallest base, like 2 or 3 or something like that. And then the second thing here is how can I get rid of this 1/4? Okay, so that's going to be the trick. So what we're going to have here is the minus 16. How can I write the 16? And now remember that this minus is not included in the 1/4 exponential power. So what I do here is a minus, then I'm going to have a 2 times 2 times 2 times a 2 to the 1/4. Okay, because that's 16. But you can rewrite it using the exponent, which is a 2 to the 4th. Right? So you got 2 to the 4th to the 1/4. And applying the power rule, we can say it's going to be minus 2, 4 times 1/4, but that's just 1. Right? So your answer should be minus 2. So as you can see that, what I did here is that I tried to make the base, rewrite them into smallest base I can find, in this case, a 2. Then I used the laws of exponent to eliminate that rational exponent to find out what it is. Now remember, you cannot use a calculator on the test, by the way. So you're going to have to do this by hand. Let's look at another one. Okay, so this time I have like 8 over 27 to the 1/3. Okay. Well, this is more like a cube root, right? Because it's a 1/3. So I mean, you can rewrite them as like this, but the one thing that we don't want to do here is that we want to there will be a time that you want to rewrite the rational exponent into the radicals, but it's not a good practice. So we're just going to stay with the rational exponents. So we can reapply the power rule to top and bottom, which is 8 to the 1/3 and the 27 to the 1/3. Now, as I did from the previous problem, we're going to rewrite the base using smallest base. So in this case, I can have what? 2 times 2 times a 2 to the 1/3. And the 27, same thing, it's going to be 3 times a 3 times a 3 to the 1/3. So if I rewrite this using exponents, I have what? 2 to the cube to the 1/3. Then I have a 3 to the cube 1/3. Now apply the power rule here, then we get what? 2, 3 times a 1/3, and the 3, 3 times a 1/3. Oops. Let me just do that. Okay. Times 1/3. So that will just get 2 over 3. Okay. So the other thing that we're going to have to be careful is that, you need to take care of the minus sign there. If you don't take care of the minus sign, it's going to be, problem there. So whether that minus sign is included inside the parentheses or the outside of the parentheses is going to make the difference there. Okay. Can I do one more? Let's try one more here. So this time I want to try minus 125 with the 2/3. This is an interesting one. Again, we want to rewrite the minus 125 with the smaller base. But if you rewrite the minus 125, you would have like minus 5 times minus 5 times minus 5 and the 2/3. But if I use the exponent on that, you got what? Minus 5 to the cube. Then you have a 2/3. So 3 and 3 cancels out. You're going to get minus 5 to square. Now you get 25. So this is why, you need to be careful about, taking care of the minus sign. And if you're not careful, then you're going to be end up with the wrong answer. So we have a pretty good idea what we need to do here. So we are going to use this idea we are going to simplify, multiplying and dividing. Then we're going to simplify these things and see if we can use this idea to tackle more complicated problems here. Okay, but let's try with the simple one over here. So if I have something like, okay, I have a 3 to the 1/3 times 3 to the 5/3. And now you're going to have to remember, you're going to have to use a product rule here, right? This will be a 3, 1/3 plus 5/3. That would be a 3. That would be 6/3. Then there would be a 3 to the square, and that's going to be 9. Oh, I forgot to mention the one thing. There will be a, if you go to the assignments, I'm going to make a folder for you guys can submit for the extra credit. Okay, so I'm probably going to ask you to, okay, I want you to upload this in-class assignment to the, to the extra credit folder, and then, when you submit it, then at the end of the semester, I'm probably going to use it for your benefit. The extra credit that I'm going to ask you to submit will not have any due date. As long as you submit it by the end of the semester, then you will get credit. I don't know how much credit that I'm going to give it to you, but it depends on what you're going to submit. Okay, so if you submit everything that I ask you, and you are maybe, I don't know, percentage below passing or getting an A, and then I'm going to use that for your benefit, so you can pass the class or getting an A and things like that. All right, so I will probably have that folder ready for you. We're going to probably do that one of the extra credit assignments tonight. All right, so we are going to apply all these exponent rules here, and here I want to show you some challenging problem here. So let's try one of those. Okay, so here is the problem. I have 64 m to the 1/2, n and divided by m to the negative 2 and then n to the 4/3. And everything is going to get raised to 1/2. So this is going to be very similar to the first question on the test last time you guys took, but this thing just becomes the rational exponent. So if you look at the inside right now, I mean, you can take care of all the inside, then apply the 1/2 outside. Or you can just apply the 1/2 everything now so you don't have to worry about it. Then after that, you're going to take care of the inside. So what we're going to do now is that let's just apply the 1/2 outside, everything inside. So we're just going to use the power rule of the exponent. We're going to apply that. So first, you got 64. Then multiply that by 1/2. You got 64 1/2. Then you got m 1/2 times 1/2. Then n 1 times 1/2. Same thing over here. You got m minus 2 times 1/2. You got n 4/3 times 1/2. All right, so that looks okay. Now we don't have to worry about the 1/2 outside. It's already evaluated inside everything. So let's just look at the each term first. So you got 64 to the 1/2. Now remember that anything to the 1/2 power was a square root. So if you look at the 64 to the 1/2, this is simply square root of 64, and that's just going to be 8. So we have 8 over here. Now, 1/2 times 1/2, we get 1/4. Then n to the 1/2. Now bottom here, you got minus 2 times 1/2, so you're just going to get m to the minus 1. And the 4/3 times the 1/2, so that would be n to the what? 2/3. Okay. So now we took care of the the exponents. Now we're going to have to simplify the m with m, and then n with the n. And the strategy here is that if you have anything negative, okay, you might want to bring it up or down, make it positive. So we're just going to stay the positive. And if you have a both positive, then you're always going to move the smaller exponent. So if you look at the on the first one, you got m to the negative 1. Oops. And the you got m to the 1/4. So since I have a minus 1 at the bottom, I'm going to bring that up to the top. So that means I got what? 8 m 1/4 times m to the 1. Now here the n, the 2/3 is going to be bigger than 1/2. So I'm going to bring the 1/2 down. So n 2/3 times n minus 1/2. So now if I combine the m, 1/4 plus 1, you get 5/4. Okay, so you got m 5/4. And bottom over here, okay, you got 2/3 and the minus 1/2. So we need to come up with the common denominator here. Okay, so that would be 6. So if I rewrite the n, you will have what? N 4/6 minus 3/6. Okay. So you have what? 8m 5 over 4. And if you subtract 4 minus 3, you get 1. So you got n 1 over 6. Okay. Are there any questions? So now, as you can see, that this is simply the simplifying the, the exponential terms, expressions. Is, the only thing here is that now you're going to have rational exponent rather than just the whole exponent, right? So that's the only thing that's going to make a difference there. You can always combine these, or subtract, multiply. You can do a lot of things like that, but the only thing that you're going to have to remember is that whenever you do this type of operation, you have to have the same base to apply the rules of exponents. Okay, so let's remember that. So let me just do another one there. So now sometimes it is much easier for us to simplify the radical using the rational exponents rather than using the radicals. So the one example will be something like this. So if I have a cube root and I have a 64 x to the 6 and y to the 3. So we want to simplify this. So rather than using it cube root, we're going to put them into the rational exponent. 64 x to the 6, y to the cube to the 1/3. And then apply the rational exponent 1/3 using power rule to all the components inside. So you will have 64 to the 1/3. Then you got x to the 6 times 1/3. Then y 3 times 1/3. So this becomes much easier. So if you look at the 64 to the 1/3, you can rewrite it as what? 4 times 4 times 4 to the 1/3. Over here, 6 times 1/3, you get square. And y 3 times 1/3, you get 1. So the first one is going to be 4 to the cube to the 1/3. Then x squared y. But 3 times 1/3, because of power rule, we're just going to get 1. So that should be 4 x squared y. So that's not bad, right? All right, so what we're going to do now here is that, what if you have some, you need to now evaluate the radicals, okay, and the multiplying and dividing and the radicals and things like that. Okay, so we're gonna look at that part. Okay, so we now understand how to apply the rational exponents. So now we're gonna go back to look at the radicals. Okay, so instead of using the rational exponents, now we are going to just use the property of the radicals. Okay, so the one of the radicals property is this. If I have, if you multiply square, it's not a square root, but any radical a times the any radical b. Okay, then you're going to get a times b. We call the this number, not the number, but the value inside, we call this radicand. And the this n over here, we call this index. So index is kind of representing the power of the rational exponent. Okay, but if you have a same index and you want to multiply, then you're going to get the same index as itself. So because the reason is that, okay, if I have, let me just rewrite this here. So let's say we have square root of n of a times square root of n over b. If I rewrite this using rational exponents, I have a is 1 over n and the b is 1 over n. And if I use the power rule, then this becomes a times b to the 1 over n. But that's simply the square root, not a square root, but the radical n. Okay, and that's just going to be n ab. And that's what we have here. Again, I mentioned that earlier, you cannot have any negative inside the square root. Cube root is okay. And the other rule that we need to remember is all the rules of exponents that that we just mentioned. Okay, and the other thing here is that when we're talking about the radicals, it's going to be critical that instead of using calculator, if you want to do this by hand, we always want to rewrite the radicand, whatever the number inside, into the smallest base, like 2 or 3, and then rewrite them in the exponential form so you can eliminate the radicals. I'll show you in a minute. Okay. So if you want to use the property there, so for example, let's say I want to. Okay, let me give you an example. Let's say we want to evaluate this 128x squared. There's a couple of ways we can do that. Okay, so for 128, okay, we can rewrite this. I'm just going to use the tree here. So, okay, so if I divide the 128 by 2, I get 64. Again, I'm going to divide it by 2, I get 32. Then divide again by 2, you get 16. Again by 2, you get 8. Again by 2, you get 4. Okay. And then finally, you get 2 and 2. So the 128 is simply 2 times 2 times 1, 2, 3, 4, 5, 7. Okay. So that's what the 128 is. If you want to multiply by 2 7 times, that's what you're going to get. So the 128 square root of 128x squared, you can rewrite this something this way. 1, 2, 3, 4, 5, 6, and 7. Then you got x and x. So what we require is that, we're going to have to pair the numbers and the variables to get them out of square root. So here we're going to have to pair them like this. Okay. So whatever that I pair them, they're going to come out as 1, 2. So you got what? 2, that one, that one, and that one, and that one. And the only thing that remains inside the radical is going to be one of these 2. Okay, so then we'll have square root of 2. So 2 times 2 times 2, you get 8. So now you have 8x square root of 2. And that's going to be evaluation of square root of 128x squared. Now, the question here is that, okay, is this really necessary? I mean, do we have to do it this way? I mean, if you get stuck, and this is the only way. But, you can always, do the same problem without actually, using the tree, writing out using the, smallest base and how many times they're applying, and then put them in back to the radical and, just pair them and take them out. I mean, that's okay. But if you have complicated problems, then you don't want to do that. So the other way that we can do this is, what we have done so far. So you got 128x squared, right? So we might want to break this into, like, for example, 64 times x squared times 2. Okay, and we have the loss as, if you, what we just looked at, if you have a square root of n of a times square root of n of b, then you get an ab inside. So that's what we have here. So you can actually rewrite this as this: square root 64x squared times square root of 2. So if you use the rational exponents, you can have what? 8 squared x squared to the 1/2, and then square root of 2 still out there. Now apply the power rule. So 8 to the 2 times 1/2, you get 1. So that's just going to be 8. And x squared times 1/2, you're just going to get 1. You get 8. And square root of 2 is remaining. So, either way that, you can use methods to evaluate these. Okay. I'm not going to say which one is better, but I know that some students feel more comfortable, doing the way that I just did, or the second way. It's up to you. It's not going to make any difference. But I must say that the first method that I showed you takes a long time, because you're going to have to come up with the, what's going to be the base to multiply to. So sometimes students find that a little bit more cumbersome, because they don't want to go through that tree factoring there. But either way, that would be fine. Whether you do it on the first method or second method, I don't have any preference. But you're going to have to understand. You're going to have to simplify this as much as possible. Now, I just want to show you the multiplication of the radical. Okay, so multiplication of the radical. Now, when you multiply 2 radicals, okay, the one thing that we have to remember is that as long as they have the same index, they can multiply. adding and subtracting is a little bit more complicated, but multiplying of radicals, as long as they have the same radicand, the same index, I mean, same index meaning the power of the rational exponents. So as long as they have the same index, okay, you don't have any problem multiplying it, okay? So, what I mean by that here is that if you're going to multiply square root x times the square root of x, that's okay. That's all, you're allowed to do that. Now, what if you have something like this? You got square root of x times you got cube root of x. Now here, the first case over here, then you just multiply square root of x times x. Okay, that's what the law says here. If you have the same index, here's an index is going to be square root 2. Okay. Oh, sorry. The problem comes in that, if you want to multiply the index that's different. So this one here, index is going to be 1/2, and this is going to be index as 1/3. So if I rewrite this, we are trying to do this. X to the 1/2 times x to the 1/3. So if you want to multiply the different index over here, you cannot do it as the radical. You're going to have to, rewrite them in the rational exponents, then apply the product rules of exponents. So here, in this case, you're going to have to find the common denominators. So in this case, x to the 1/2 plus 1/3. Okay, so that would be 3/6 plus the 2/6. So then you will get x to the 5/6. So it's not impossible if you have a different index. I mean, you can still do it. The problem here is that you're probably going to have to convert that into the rational exponents in order to do that. But if you do have the same index, you're just going to multiply whatever is inside. Okay? So let's try a few examples here using this idea. So let's say I have something like, square root of 3 times the square root of 15. Now, one thing that we have to be careful when you multiply these radicals, after you multiply the radicals, you're always going to have to simplify it. Okay? And if you don't, then, we're going to have, you're not going to have, if I ask you to simplify the radical and you don't multiply and simplify, and if you don't simplify it, then that's not complete, right? So since this example, we have a same index, right? We have a square root and the square root. So we're going to multiply these two, just like what you see there, just like what I see, what I did here. So then I have a square root 45. That's okay. Now, is a 45 the simplest to form? Well, it's not, right? So you can rewrite this as what, 9 times 5? But you know that, 9 is a 3 square. So you can rewrite this as square root of 9 times the square root of 5. But you have a square root of a 3 square times the square root of 5. But this is going to be same as what? 3 squared to the 1/2 times the square root of 5. So that's just going to be 2 times 1/2, that's going to be 1. So you got 3 square root of 5. So that should be the answer, not square root of 45, okay? So if you have two radicals multiplying one another like this with the same index, you just multiply the whatever the value you have inside the radical. And when you finish, make sure that you simplify, okay? And write it as simple as you can. Now, let's look at another example here that involves a little bit here. So this time I have 3 cube root of 4x times cube root 2x to the 4th. Okay. Everything. Well, the only thing that I can see here is that we have cube root on both of them. Okay. So the way we're going to do that here is that, but the other thing here is that we got 3 outside of the cube root of 4x. So since we have a cube root on both sides, I can just multiply these two. Okay, let's just do that. So you got 3, and I have a cube root here. So 4 times 2, I got 8. Then x times x to the 4th, I get x to the 5. Oh, that's nice, but we still need to take care of this 8x5 here. So what I'm going to do here is that I am going to rewrite 8 as a base 2. Okay, so that means 2 times a 2 times a 2, then x to the 5. And that will give us the 1/3. So then we have a 2 to the cube times x to the 5 to the 1/3. Okay. Now here's the one thing that we have to be careful here, right? Because we want to, take out the simplify as much as we can when we apply the 1/3, the root x, a cube root into the 2 to the cube and x to the 5. So if I rewrite this one more time, I can rewrite it as 2 cube x cube, then x squared to the 1/3. Okay, so now apply the power rule here. Then I have a 2, 3 times 1/3, x 3 times 1/3, and x 2 times 1/3. Okay. So what we got here is that 3 times 2 and 3 and 1/3, you get 1. So 2 to the 1. Same thing over here, x to the 1. Then I have x to the 2/3. Okay. So the only thing that we have a rational exponent is going to be another 1x here. So we get 6x times the x to the 2/3. If you want to rewrite it in the radical form, okay, the number at the bottom, the denominator, is the one that's going to be your index. Okay, so here this 3 is going to be your index. So you can write it as 3 over here. Then the other one goes inside the radical. Now, is it necessary that you need to write it as a radical? It depends. If I ask you to write it as a radical, which is much more cleaner, I think, then, you just have to remember that a denominator is going to be your index. Numerator is the one that goes inside. Okay? So that's what we have here. There are also, sometimes that, you don't want to write it as the rational exponent. You just want to do it inside the radical itself. So let's just take a look at that one. All right, so here, we want to look at example. We're going to do this, everything in radical. So here we have fourth root. Then I have a 27a squared b to the 5. Then we're going to multiply to the, again, fourth root. Index is also 4. And I have a 6a cubed and the b6. Okay. So here let's not use the rational exponent. We're going to do this using just the radicals and the radical properties there. Okay. All right. So what we're going to do now is that we're going to multiply, since we have the same index. We can do that. So that's no problem there. So I'm going to put it under the big fourth root over here. Okay, so you got 27 a squared b5 6 a cubed and the b6. Okay, that's not bad. All right, so all you have to do now is that just take care of the inside. So here we're going to have what, 27 times a 6. And then we got a couple of a's and the b's that we need to take care of it, right? Okay. Now we need to look at how we're going to take care of it. Remember that this is the fourth root. So whatever we do, we want to have the exponent. If it's possible, we want to put them in like a factor of 4. Okay. So if I rewrite this, okay, now let me just look at the 27 first. I am going to rewrite it in base 3. So that's going to be what? 3 times 3 times 3. Then I have a square b5, but 6 you can also write it as a 3 times 2. Then I have a cubed and the b6. So we're going to take care of the number first, and we'll come back to the variables here. So if you can see this one here, I got 3 3's here, and I have another 3. So I can rewrite them as the 3 to the 4th, right? So let's just do that. So I have 3 to the 4th. We are going to, then we have 2 left over. Then we're going to take care of the a. Okay, so here a squared and a to the cube. So if I apply the product rules, that will be a to the 5th, right? And the same thing for the b. We're going to take care of the b over here. b5 and the b6. So that will give us the b11. Okay, so what we need to do now here is that we're going to have to somehow get these the constant and the variable out of the fourth root here. So as I mentioned, this is the index is equal to 4. So we want to put everything in terms of exponential power over 4. So we already did that for the 3 to the 4th. This one here. And we're going to do that for the a and the b. So let's just do that. Okay, so we still have 3 to the 4th times 2. Now a to the 5, I can rewrite it as a to the 4th times a to the 1. And the for the b, I can do b to the fourth, and b to the fourth, and b to the cube. Okay, because 4 plus 4 plus 3, you get 11. All right, so whatever that we have exponential power with the 4 in it, we can take them out because the 4 times 1/4 is going to give you 1. So the one that we are going to take out is these here. 3 to the fourth, 8 to the fourth, b to the fourth, and the b to the fourth. So those are going to come out as one single constant and the variable here. So that means I have a 3, a, b, and b. And the cube fourth root, you got 2, then a, and b cubed. So that simply gives us what? 3 a b squared. Fourth root, and I have a 2 a b cubed. Okay. So in this case, we didn't use any rational exponent. We just did everything inside the radical without converting anything into the rational exponents. The other thing that sometimes is useful here is that if I have a same, index with a different radicand like this, you can combine this into one, or vice versa. So this is another way that you can, combine some of these terms. And if I have two separate radicals on top to bottom, but I want to simplify them, you can just put them into one radical and just take care of that without just having any problems there. Okay, so let me do one of these. Okay. So if I have something like this, let me just go back here. Okay. I have -2 cube root 54a. Then I have a cube root of 2a4. So let's say we have a problem like this. The best way here is that you want to combine these, then you simplify them. Okay, so the rule says we can combine the radicals as long as they have the same index. So we can just do that. So -2, you got cube root. I have 54a divided by 2a to the fourth. Okay, then use the the laws of exponent. We can kind of simplify them. So coming down here, you got -2, so you got cube root. So 54 divided by 2, you get 27. Now here, you can bring the a to the bottom, which becomes a to the -1. Then apply the product rule, so we get a to the cube. Okay. So if I rewrite this, I will get -2 cube root. You got 3 times 3 times 3. a times a times a. So I have a minus 2, 3 over a. Okay, so the answer is going to be minus 6 over a. So combining the radicals into one radical sometimes help us to, simplify some of the complicated, problem into a more easy one here. Let me see if you guys had the, okay. Yeah, let me do one of these here. So, okay, so we are going to simplify this. I have a square root 96 a5, okay, b minus 3. Okay, and divided by square root 3 a to the minus 5 b. Okay. Now I'm going to combine this into one so I can simplify this. So I have a square root 96 a5 b minus 3 3 a minus 5 b. So once you put them into the under the one radical, then this becomes a matter of simplifying the exponents. Okay, so let me just bring this up a little bit here. Okay, so let's just take care of the numbers first. So you got 96 divided by 3. What? These two. Okay, so you got 96 here and the 3 over here. So that would be what? 32. A5 and A negative 5. So I'm going to bring the negative 5 to the top. I have A5 times A5. I have a negative on top, B minus 3, so I'm going to bring it down to the bottom. So that would be a B times B to the cube. Okay. So here, if I combine them, I got 32 A to the 10 and B to the 4. Now at this stage, if you want to, if you feel more comfortable using the rational exponents, I don't have any problem. If you want to do this as the inside the radical, that's okay too. But it's going to be up to you. So if you want to, let's say, I want to use the, the rational exponent because it seems a lot more clear. So then you can rewrite this as something like this. 32 A to the 10 over B to the 4th and 1/2. Okay, so it's going to be a preference there. But the thing here is that when you do this way, inside the radical, you're going to have to remember that this is a square root. So you want to have exponents factor of 2, like 2, 4, like 8, 10, and things like that. So that's the one thing that you're going to have to remember. Over here, the if you want to use the as a rational exponents, you're just going to have to apply this 1/2 to everything inside. Okay, all right. So what we're going to do now is I'm going to use the radical over here, and I'm going to put, okay, I'll show you both ways. So this one over here is going to be 16 times 2. I'm just going to write this here. 16 times 2. And then I'm going to break the A10 into 5 and 5. Is that right? No. The A to the 4, A to the 4, and A to the 2. Right? Because of 4 plus 2, you get 10. And the bottom here is just going to get b squared. I'm trying to write this as small as exponents, but as you can see, that 4 is a factor over 2, so I don't have to go any further. Now the 16 here is going to be what? 4 squared, right? I have a 4 squared times a 2, a to the 4 and a to the 4 and a squared. And then we have a b squared and b squared. So inside the radical, anything that has the exponential power with the factor over 2, if it's a square, it come out as 1. If it's fourth, it's come out as a square, and so on. So the 4 square is going to be come out as 1 4. 2 stays inside. A4 and A4, they'll come out as a square and a square. And a square come out as a. And the bottom one, you come out as a b and b. And the only thing that's going to be inside the radical would be a 2. So then we have what? 4 a to the 5th over b squared. You still have a square root of 2 there. Okay. But if you want to do this using the rational exponent, let me just do that here. Let me just rewrite that. Here I have now 32. What was this? A10B4. 32. A10 B4 to the 1/2. So we want to apply the 1/2 to everything inside. So let's just do that. Okay, so I'm going to do 32 to the 1/2, A 10 times 1/2, B 4 times 1/2. So 32 to the 1/2, then I have a what? A to the 5th, then you got b squared. So the only thing that we're going to have to worry about here is going to be 32. But you can say, something like that. You get on the 32, you're going to have a 2 times 16. So you got 4 squared to the 1/2. Then you got A5 and the b squared. So apply the 1/2 to both 2 and the 4 square. So you end up with the 2 to the 1/2. Then 4, 2 times 1/2. And you got A5 and the b square. So now you will have what? 2 to the 1/2. 4 A5 and the b squared. And that's pretty much what we have in on the other method here. So, if I don't say anything, then you can use, however you want to, whether you use the irrational exponents or the using radicals. It's, whichever, you feel more comfortable, use that. I want to show you another one. I think this is what we already talked about a little bit. What if I have something like this? I have a 4th root of 8 times the cube root of 5. I mean, if you just look at this as it is, there's no way that you can evaluate this unless you use the calculator or something. So this one cannot be done, right? That's you would say. I'm not sure, right? But let's just find a way that we can do this. I'm sure we have some way to do this, right? So if I want to rewrite this using rational exponents, I have 8 to the 1/4 times the 5 to the 1/3. That's what this is, right? We convert the radical into the rational exponents. So the next thing that we are going to do here is that, okay, why don't we just rewrite the exponents using same common denominator for both base 8 and base 5. So if you look at this exponent here, it's going to be, one of them is going to be 4, the other one is going to be 3. So common denominator is going to be 12. So I'm going to rewrite this, okay, using denominator 12. So that's going to be same as the 3 to the 12. Then you have a 5 to the 4/12. Because a 3/12, if you simplify it, that's what you get, 1/4. And if you simplify 4/12, that's 1/3. Okay. Oh, that's fine. Now, if we somehow, if we can move this, okay, now we know that they have the same denominator, right? So what we want to do next is going to be, we are going to take the rational exponents of 1/12. So we're going to do it this way. 8 to the cube. And then I have a 5 to the 4th. But we're going to take out the denominator part of 1/12. Okay. So now here we can actually multiply this, 8 to the cube. I don't know what 8/cube is. I just use the calculator here. So here, 8 to the cube, that's going to be 512. And the 5 to the 4th. I have a 625. And you multiply that, 512, I get 320,000. To the 1/12. And now you have the radical. Index is a 12. The radicand is going to be 320,000. Now, does it prove anything? No, not much. All we can do here is that, we can show that even though we have a different base, we can still put them into the radical form, but you're still going to have to use your calculator to find out what is the 320,000 to the 12th power, right? So that's not going to be something that you want to do by hand, right? Because it takes a long time. All right, now the the other thing that I want to show you is that even though you have some other different base, sometimes you can still come up with the nice numbers there. So I'll show you with that, and maybe I'll split you guys into a group and we'll do an extra credit problem today. So here's the another example here. This is going to be different, same kind of problem. Okay, same thing. You got this is the 10th power with the 6 there. All right, so we are going to rewrite this using the rational exponents. So here we have what, 8 with the 1/5. Then we have a 6 with a 1/10. Okay. Here we are going to, if you look at the 1/5 over here, like what we just did, we can rewrite that using the same denominator, right? So you get 8. Then it's going to be what? 2/10. And then you got 6 to the 1/10. Okay. So we're going to take out the 1/10 as our common exponent. So you got 1/10 here. So here we have what, 8 squared times a 6. Now that we can do, right? 64 times a 6. I have 384. Okay, because the 64 times 6, you get 384, and this is going to be 1/10. Now, I'm not sure if the 384 is anything. Let me see. 2 to the 10. That's not it. Wait. Really? 10th? Oh. No, that's right. Okay. So I want to make sure that 64 times a 6. 384. So 384 to the 1/10 power. We need to know what this is. And I don't know. Okay, so I got 384 to the 10. No. Okay, 5. Let me go over this, see if I made any mistake here. Okay. Hang on. 2. No. I got a little bit more than I'm supposed to have. Let me see. Really? Because I don't see that there. Did I write the problem wrong? No, that's fine. Okay. So I guess a weird number. You guys getting that? 384 to the 10. I get about like 1.81. Is that what you guys getting? Well, if you round it up, you get 2. But, you know, I use the calculator. I got 1.81. Should have done the other way. Let me see. Okay. Yeah, I think they estimated that. But, you know, like I said, you know, it can be done, but you're still going to have to use a calculator. Otherwise, you won't be able to get this number at the end. Okay. All right. So
I got 38.4. Does that sound?
how did you get 38.4?
I don't know. I put it into a calculator.
Huh? No, this is a 1/10 power.
Yeah, I put that into my calculator. Give me 38.4.
No, you're not dividing by 10. Did you enter your numbers correctly?
I think so. But let me
I don't know. If you have a calculator, you should have something like this on the. You're gonna have to push this. So you're gonna have to put 384, then push this one, then 10. Does that make sense?
Yeah.
And so in other words, that's 384. Then push this, then push 10. And you probably get like 1.81. It's close to 2. Yes?
Still got I got 6.97 when I did that.
6.97. That's kind of weird. Because if you want to do this, like, you know, 2 to the, okay. What did you get? 3 point something? 6 point something?
6.97, yeah.
That's kind of weird. Huh. I'm not sure. Yeah, it's gonna be like 1.85, 86, 87, something like that. Okay.
I'll try and
You
see if I'm
still have
doing
a
something wrong
problem?
with my calculator.
Huh?
I'll try and see if I'm doing something wrong with my calculator.
So
I
what,
must-
you know, so this thing here is that if you actually do this, you're gonna have to carry some decimal here. So if I have 384, that, and 10, you get like 1.8131 or something. Okay, so if I just round this up to maybe 1.84. Now, if you multiply 1.84 times 10 times, we're going backward, and you're supposed to get 384, right? And so you're just going to do that. Okay. Well, I think I went up too much. 1.82. Something like that. So 1.82 to the 10th power, get about 398. So 1.81 should be fine. Yeah. So, I mean, this is something that, you know, we can do, but like I said, you know, at the end, depends on the what exponential power you have. You're probably going to end up with the using calculators. So, you know, it can be done, but, you know, so in this case, you probably end up with something like this. Okay, that's what you have. Okay, so it's not going to give you exact value here. Squared, I mean, 10th root of 384. It's gonna be like 1.81 something, 1.813, you know. So you're not gonna get the exact number here. Okay, so it has to be a little bit, tricky. But the process is, everything looks fine. It's not going to be something that you might want to use it, but we can still do it using the properties of radicals there. Okay, so I can give you guys a break, then we come back and then do the extra credit problem. Or I can give you extra credit problem, then when you finish, then you can go home. Which one would you like to do? You want to take a break first? Or
I'm into just doing the problem and then leaving after.
Yeah, let's do that.
all right, sounds good to me. So now remember that when you guys finish this, I'm gonna put you guys in the break room. I want you to talk about it. So when you guys, after you guys work this thing together, then when you finish, I'm going to show you where the area that you need to submit this. Okay, so as an extra credit. So here's the question one. I will give you two problems. So question one, simplify. Okay, so I have, what do I have? Give me a second. Why I'm coming? Oh. Okay. I have x 2/3 y minus 1/3 8 x to the 1/2 y to the 1/3. Okay. Question two. Okay. Simplify again. Mm-hmm. 90 x cubed y minus 1. Okay, divided by square root 2 x minus cube and y. Okay. Do you guys want to go to the break room or you just want to do it here? I don't have any problem. Why don't we just do it here? You can discuss if you want to. Don't mind me, okay? I'm going to create the folder for you. Oh, hang on. So when you finish, if you want to check, ask me, see if you have a correct answer. Okay, then I'll tell you. Okay, so.
I think I have the answer for the first one. Can I check?
You want to check your answer?
Yeah, I got x to the 1/18 over 2y fourth. Wait, 2y to the 4th over 9.
Why don't you share your screen? Let me just stop this. Okay, go ahead, Tim. Show me
I don't know.
what? I can't see, dude.
Oh, it's so small. Wait. Let me just write it bigger on some piece of paper.
What is this? X to the 18. Correct answer.
That's
Yeah.
the right answer.
Mhm. That's correct.
Okay. And then I got the second one too. Is this right for the second one?
Second one, give me a second. Let me see that. Yes.
Okay. So I can go now.
Yeah, and make sure you submit it.
Okay, bye.
Do we have another Zoom meeting on Monday?
No, I said we're not going to have any Zoom meeting next week, but we're gonna come back Monday, not next week, the following week. So next week we're gonna have a YouTube asynchronous video lecture. We'll be coming back on the 26th in Zoom. That's Monday.
Oh, okay.
Okay, but 19 and 21 next week is going to be a asynchronous lecture.
So when we're done, we just upload it to Canvas.
Oh, yeah, but
Thank you.
do you want to check your answer before you submit it?
I actually wrote down what the first guy said, and so I just
Okay,
yeah.
that's fine.
Thank you. Okay,
Mhm.
thanks.
Bye.
Bye.
Do we have to submit it by today?
No, you don't have to. As long as you submit it by the end of the semester, you can still get some credit.
Okay, sounds good.
Okay.
I'm gonna go. Have a good night, Professor.
All right.
All right, I'm leaving out.
Say
Have a good
again.
night.
Okay.
All right, Professor. Thank you. Have a good night.
All right. See you. 그렇게 나눠 갖고 해야 되는 거 아니야?
Travel. At Camping World, we have an RV for every lifestyle and budget, starting at